Hello everyone, and welcome along today to our Civil and Structural Engineering Masterclass today on Assessment and Strengthening of Infrastructure. I'm Debbie Rodriguez and I am your host for today's session. So in a moment, I will introduce you to Dr. Benny Suryanto, who will talk you through our current areas of research within this area, and then move on to the main body of the presentation. We'll then discuss the postgraduate programmes that we have within this area, talk a little bit about scholarships, and then we'll move to the question and answer session at the end. Now, our Q&A chat function is open from now, so we invite your questions from now and we will answer those questions and address them after Benny's presentations. So Benny, would you like to talk through your presentation, please?
Thank you very much, Debbie, for the introduction. Can I just check if you can hear me okay?
We can hear you and we can see you, Benny.
That's brilliant, yeah. Hello everyone, my name is Benny Suryanto and I'm the program leader for the MSc in Civil Engineering and Construction Management and also Civil Engineering with Industry Placement. Today I'm going to give you a bit of flavor about various research and teaching activities that we do here at Heriot-Watt University. Let me start with what civil and structural engineering is all about. As you may know, civil and structural engineers are responsible for the design and construction of many things around us. So if you think about buildings we are in, transport infrastructures like roads, railways, underground metros we use every day, bridges we cross when we get to work, airport that we use when we are on holiday. So, and all other key infrastructure. So all of them are designed, constructed, and also maintained by civil engineers. So this shows the key roles that civil and structural engineers play in the society and is shaping our future. Given the important roles of civil and structural engineers for our future, at Heriot-Watt we align what we do in terms of research and teaching to the UN Sustainable Development Goals. So in the next few slides, I will briefly talk about a few projects that we run in collaboration with industry or funded by the government under this remit. Next, please, Dave. The first one is related to our work on sustainable transport infrastructure. At Heriot-Watt, we have the largest fatigue testing facility in the UK called GRAF2, capable of testing large-scale highways and railway components under fatigue over millions of cycles. We have specifically used this facility to test full-scale ballast, slab track for high-speed railways, and other important components. We contributed to the SS2 project in the UK with a number of industry partners in Europe. With this facility, we can apply cyclic load at a very high frequency. So typically about 10 Hertz, so it's about like 10 cycles per second. So this allows us to apply the equivalent of 30 years of cyclic loading in about 4 to 5 weeks only in the laboratory. So when there is a new development on sleeper or slab track, we can first assess their performance and test it full scale before using it in practice. Next slide, please. The second research activity that we do is related to sustainable water infrastructure. For example, one of our colleagues here, Professor Bhaskar Sengupta, he installed the world's first chemical-free water treatment plant in South Asia, around India, Bangladesh, in other parts of the world, like in South America. The main purpose has been to help local people to get access to clean and safe drinking water. We also have a government-funded project led by our colleague, Professor Scott Arthur, who initiated work in the area of blue-green infrastructure, combining green spaces in urban area like park and gardens with blue elements like ponds and river. So as a means of tackling issue related to urban flooding. Next, please. Another work that I would like to introduce just briefly on sustainable construction materials. This is the first one is on the development of ultra low carbon eco brick, which contains 100% recycled materials. So this is led by our colleague Professor Gabriela Medero and her team, comprising actually postgraduate students. They've launched a spin-out company called Kenotech quite recently, and their product has been recently nominated as the Product Design of the Year at the Museum Design in London. Well, there is a link shown on this slide, so if you want to know more about this, feel free to put the link on your browser. More recently, we have also started working on the development of low carbon materials for 3D printing. Shown on the right-hand side of your screen is a project run by our MSc students. So as part of his dissertation on the development of low carbon material for 3D printing applications. Next, please. Right, so that's only a very brief overview about what we do, and let's now move to the second part of my talk, which is about the assessment of edging infrastructure. So next, please. So today I will focus on a specific connection geometry used in bridges called a half joint. This is also known as dub-end in the US and also in North America. This type of structural connection can be found in many bridges around the world. In the UK, we can find easily this form of connection on bridges that run over a motorway, as shown on your screen. This type of bridge usually consists of 3 spans. So we have 2 side span and a central span. So central span is suspended and supported by the 2 outer span through a special connection. So it's the shape is just like an L. We call this one as a nib. So we have a pair of these. So we have upper and also a lower nib. Due to the geometric form of the joint, there is also a small space between the two. You can see there's a gap there, and access to this space is protected by expansion joint on top. This type of connection is popular because it simplifies the design and construction processes. However, it comes with a cost, so inspection and maintenance are very difficult. After many years of service, the performance of the expansion joint generally reduces, and quite often, water containing salt start to leak into the joint, to the gap between the 2 parts, and accumulate above the lower part. And this salt water can actually accelerate corrosion process of the internal steel reinforcements and reduce the overall capacity of joint. In some cases, this has led to a full collapse of bridge. Next slide, please. To put the importance of this work in today's world, this slide shows an example of deteriorated half joint bridges on the Woodside Viaduct, which is a major part of the M8 motorway in Glasgow, which is just less than an hour from here in Edinburgh. Well, as you can see in the joint region, we can see water staining on the surface. We can also see visible spalling of concrete due to corrosion of internal reinforcement. So we have done inspection, periodic repair and maintenance, but accurate assessment of the residual capacity of this deteriorated joint like this is very, very difficult, because all depend on the condition of the internal reinforcement, which is actually not visible from outside. So to study the effect of this deterioration process at Heriot-Watt, we have recently completed a few series of large-scale experimental testing and numerical studies. So I will briefly introduce this. Next slide, please. So this slide shows the experiment that we have done very recently. We first designed a number of reinforced concrete beams with half joint geometry at both ends. You can see there's a protruding side at both ends of the beams. The beam shown on top had a full reinforcement detailing. So this is to simulate the condition of new structures. Well, as you can see, the internal reinforcement configuration is very, very complex. I've made them in different colors just for visibility, but they're very complex, as normally we use in practice. We also designed several other specimens. For example, the 6 cases shown underneath had different types of extent of deterioration. So we just want to simulate the deterioration in this specimen. And we have done this by simply removing some of the internal reinforcement. So for example, the first case shown on the top left, the diagonal reinforcement was removed. This is just to simulate severe corrosion of the diagonal reinforcement near the corner. Well, you can see 5 other deterioration cases on your screen. And what we did, we tested each and every half joint in our heavy structures lab, as shown in the right hand side of your screen. And we had our postgraduate students joining the test as part of the delivery of a few technical courses that we do here at Heriot-Watt. Next, please, Debbie. This slide shows you an example of specimen during testing. In a structural test, we normally document various things because it's a very expensive thing to do. And one of them is the relationship between the applied load and deflection, as you can see on your left-hand screen side of your screen. This gives us an indication about the response of the member. So if we apply load, then this is the response of the member, something that we cannot do in a real bridge member, but we can do this one in a laboratory. So this will give you an idea about the response under day-to-day loading condition, or even when the member is loaded accidentally to failure. During testing, we also capture the progress of crack development, as shown on the right side of your screen. As you can see, as we apply load on top, we can see the formation of crack in the specimens, and because of this, the stiffness of the member decreases as we apply further loading. This process continues until the reinforcement inside the member has yielded, and finally the member will fail in a very brittle manner, as what happened in reality. So understanding the behavior of such specimen in the laboratory is very useful and can help engineers like us to predict the residual capacity of a deteriorated joint found in real structures. So next, please, Debbie. Well, apart from large-scale laboratory testing, we also have the expertise to do some structural assessment using advanced technique. For example, we have been in collaboration with a company based in the Czech Republic called Cervenka Consulting in developing a powerful nonlinear element software called Athena. So using this software, we can simulate the nonlinear response of reinforced concrete members under general loading conditions. So it can be a new structures or even aging structures with deterioration, as what we seen earlier. Next, please, Debbie. Yeah, just to give you a flavor. So this slide shows you two examples of half joint with different internal reinforcement configuration that we use to simulate deterioration in Athena. So on the left, we have a half joint with a reduction of amount of web reinforcement. So this is to simulate what happened after deterioration in the web region. And on the right-hand side, this is the case that we try to simulate the corrosion of a U-shaped bar. So if you notice on the diagram on the top, there's a missing U-shaped green bars on the top. This is to simulate simulation that happened around that regions. So as we can see, the two joints behave very differently. And the most important thing is that, well, through the computer simulation, we can actually simulate the very, very complex nonlinear behavior that we observe in the laboratory very well. So what does it mean? It means that this type of tools can be a very useful tool that can be used for checking the effect of deterioration in real structures, particularly in terms of checking the residual capacity and the safety of a bridge in this case. Next, please, Debbie. Well, the final slide that I would like to show in this part of my talk is about our recent project that was funded by Highway England. We were responsible to test 18 large-scale half-joint girders that used to form part of an old bridge in England. So it's about 45 years old at the time. One of them weighed 20 tons. So it's really a real large-scale testing in this case. Well, the project is now complete, and we hope that the finding from this project will find use for the assessment of the bridges around the UK and also around the world. Well, if you choose to study with us, you will have the opportunity to work on an industry-funded project like this, and you can start establishing contact with industry while you are doing degree with us later on. Next, please, Dave. Right, so with various projects we do in mind, let me now introduce the postgraduate programs that we run here at Heriot-Watt. Next, please. In terms of MSc programs in civil and structural engineering, we offer 3 programs in total. So the first one is called Advanced structural engineering. Second one is civil engineering and construction management. And also we run another program called civil engineering with industry placement. So in these programs, the content of each course has been developed in collaboration with representatives from the industry, which are also a member of our civil engineering industry advisory committee. So we do this just to make sure that what we teach are relevant to the current industry needs. So when you graduate from us, you will have the skills and the knowledge needed in the current job market. Next, please, Debbie. I would like to start with the first MSc program in Advanced Structural Engineering. In this program, we put strong emphasis on technical aspect of structural engineering. We emphasize the importance of design for various types of structures, including steel, concrete, as well as steel and concrete composite structures. We also teach various assessment methods, covering different types of physical model, as well as those which are available in the design codes. In the delivery of our courses, we also use a number of advanced analytical and numerical software packages. Just to give you some examples, we use LUSAS, we use SEP 2000, Abacus, Adina, and also Athena in the various courses. A lot of our courses are also very practical. So while you will spend the majority of your study in classroom and lecture theaters, you will also have the opportunity to spend a good bit of time in the laboratory, which bring actually what you learn in class into real life practice. During a normal semester, you will have on average 12 to 16 hours contact time per week. This MSc program is fully accredited by the JBM, so it's a professional institution in the UK, which actually include other professional institutions like the ICE, ISRACI, and also the Institute of Highway Engineers. What this means to you is that when you graduate from us, you will have the academic requirements to train further to become a chartered engineer as you progress with your professional career later on. This program can be taken by those who have just completed their first degree and those who want to specialize in a particular area of structural engineering, or those who have been in the field, working in the field for some time and want to enhance their technical skills. Next, please, Debbie. The other MSc program that we have is the Civil Engineering and Construction Management that I lead. In this program, we offer a relatively large number of courses covering various topics in civil engineering. So we include structures, something related to water, geotechnics, materials, as well as safety and also reliability. So if you have a particular passion or if you want to gain specialty in a certain areas of civil engineering, you will have plenty of options to choose. If you wish to find the list of the courses we run, I will encourage you to find the list and to check our website. Apart from these technical courses in this MSc program, we also offer a number of construction management courses, which are suitable for someone who has already have a degree in civil engineering or in other engineering degrees. So you can learn project management practice as often currently required in current practice. As in other MSc program, we are also open for those who have just completed their first degree, and also those who have worked in the field for some time, who wants to specialize in a particular area in civil engineering. This program is also fully accredited by the JBM, as I've explained earlier. In this program, there's also an option to do industry placement. So for those who are still not in employment at the moment, you can choose to do this while you are studying with us. So you will be required to find a placement, and there will be a dedicated staff that will provide you support in finding your placement. Next, please, David. The delivery of our MSc program, so we have 3 in total. So all of them are supported by the state-of-the-art laboratory and computing facilities, which are in many respects world-class. Well, whenever you have a chance to visit Edinburgh, I will encourage you to visit us, to visit our campus, and you will be able to see these facilities during your visit. Next, please, Debbie. Right, so for those who are interested with the program structure, in this slide, I'd like to show the typical academic year at Heriot-Watt for postgraduate program, which is split into 3 semesters in totals. So the first semester runs from September to December, the second semester from January to April, and then the final one from May to August. So 3 semesters in total, and each semester is 12 weeks long. During the first 2 semesters, you will be required to take 4 taught courses in total. So this is for each semester, which is in this slide is represented by the 4 boxes under the September semester heading, and also under the January semester heading. There will be exam held toward the end of each semester. Some of the courses will have different assessments. We also have coursework-based course assessment. In this case, you will be required to submit your work during the semester, so that will be during the 12-week period. Once you have passed all 8 taught courses in total, you will be required to do a research dissertation toward the end of your degree. This will be during the final semesters. The topic will be something that is of interest to you. So this could be a research lab project in your specialization area, or a practical-based project in cooperation with industry partners. So you will have the choice later on. Next, please, Debbie. This slide shows the program structures for the industry placement MSc program, which is pretty much the same to the previous one. And the only difference is that once you have completed 8 taught courses, you will have the opportunity to do a 6-month placement in industry before doing your dissertation toward the end of your study. So that will extend the duration of study from 1 year to about 1.5 years in this case. Next, please, Debbie. Right, so I just want to finish my presentation with 3 main reasons why you should study with us. First is because of our reputations. Our civil and structural engineering program has been ranked top 150 to 200 in the world. This is done by the QS World University Ranking. So we have never been outside the top 200 since this ranking was established about 9 years ago. Second, it's because of our strong research. We are now ranked first in the UK for research power, which is based on it was a nationwide REF exercise in 2014. So you will have the opportunity to be part of this when you join us. And third is because of our strong connection with industry. So we work with so many civil engineering and construction companies. So every year, these companies come to us to recruit fresh graduates to join their engineering teams. So this will be a great opportunity for you. Okay, so with this, this brings me to the end of my part. So I hope that you find our MSc programs interesting and relevant to what you do. So thank you for your listening, and look forward to welcoming you to Heriot-Watt University in the near future. And over back to you, Debbie.
Thank you, Benny. So I'm going to talk a little bit now about scholarships available should you be interested in applying. So if you are an international student, then we have a number of international scholarships available for international fee-paying students. They are normally awarded as a fee-paying abatement to the fees, and what I would recommend if you are interested in finding out more information about scholarships available, then do contact the regional team manager for the area in which you reside. And I'll pause on this slide for a little moment because all the contact names are on this slide, and all of the contact email addresses as well. All of this information on this slide is also available on our website. So just take a wee look at our website for the contact details of your regional team manager. If you're from the UK and a UK fee-paying student, then we also have a number of scholarships available which you could apply for. So to find out more information, then email scholarships@hw.ac.uk or again, see our website. So if you've applied to study at Heriot-Watt University in the past, and if you have studied at Heriot-Watt for a year or more previously and are an alumni of the university, then you could be eligible for a 20% discount on fees. We also have an MRAC fellowship, which is a competitive scholarship but provides 30% discount on fees, as well as an opportunity to become a student ambassador, which is a really good opportunity and something that you can put on your CV. MRAC stands for Marketing, Recruitment, Admissions and Communications, and it's one of the departments within our university. If you're a high performing sports person, then we have a number of coaching or sports scholarships which you could apply for, and I do advise that you take a look at the website to see if you would be eligible. On our website as well, we also advertise an externally funded scholarship opportunity, which is a £2,000 bursary, which will help towards your living costs, and that is offered by Postgraduate Solutions. So I'd like to thank you for listening to our masterclass today, and I'd now like to start the question and answer session. So we have a couple of questions in the chat already for Benny, but I would like to invite you to continue to type your questions for Benny. But Benny, for now, the first question is, how many students per year do you normally take on each of the courses?
Thank you, Debbie. So typically we will have around 20 to 30 students applying to our MSc programs. So we have about 20 to 30 students. In terms of the size of our classes, this will vary depending on the course. So this will be anything between, I will say, 15 to 40 or up to 50 in total.
Thank you, Benny. And what is the balance between international students and UK students on these courses?
It varies among our MSc programs. In civil engineering and construction management, we tend to have more international students. I think the split would be about 60-40. So 60% international students and 40% home students. Interestingly, in the case of advanced structural engineering, the split is completely the opposite. So we have more home students and less international students. So again, the split is about 60 to 40%.
Thank you. Benny, there's a question that's come into the chat that is saying, is the topic you've just discussed within this webinar today taught within the courses of the programmes?
Yes, I can confirm we use this as part of our teaching delivery. So we run a number of courses related to concrete materials and concrete structures. So, for example, in the structural materials course that we deliver, we try to cover the effect corrosions on the performance of concrete and on the long-term durability of concrete. In the other course that run by my colleague, Dr. Tiberius Kotsofos, he discussed about the structural response of bridges. So bridges with deterioration can be half joint bridges that we discussed earlier today, or other types of bridges.
Thank you. I can see currently we have 3 questions left in the chat, so I'd encourage your audience to keep typing your questions. But for now, Benny, the next question is, how practical are the courses?
As I mentioned earlier, I think most of the students will spend the majority of their time in classrooms and also lecture theaters. But we do deliver practical-based courses, so they will have the opportunity actually to come to the lab, to do some hands-on activities in the lab, just to to implement what they learn in class and just try it in the real life situations. So I will say from the courses that we offer, at least one of the 4 courses will actually offer laboratory exercises. So I think that will be approximately that split.
Thank you for that comprehensive answer, Benny. The next question is, what types of software do you use within the courses?
We use various types of software related to structural analysis and design. For example, for structural design, we use SAP 2000, which is a software which is widely used in industry, not only in UK, but also all over the world. We also use sophisticated nonlinear finite element software. One of them is Athena, which is the one that I showed you earlier today. But we also use Abacus, we also use Athena. Again, these are the software that normally are used by the industry at the moment. In terms of construction management, we also use a number of software to prepare the scheduling and so on. So something like Primavera and so on.
Thank you. There's only one question remaining in the chat currently. So, Benny, what are the dissertation topics like? Can you give an example?
We have many topics that we offer in terms of dissertations, because our faculty member have expertise in many different fields in civil engineering. So in structures, materials, geotechnics, and so on. Just to give some examples, for example, my area expertise in concrete materials and structures. So recent topics are, for example, the development of cement-free concrete. So concrete that use no Portland cement at all. So this is to contribute to the net zero agenda in many countries around the world. Other topics, for example, on the 3D printing. So we try to develop low carbon material for 3D printing applications. We also have colleagues that offer many different topics in railway engineering related to high-speed railways. So, for example, my colleague, Professor Lacroix, is offering topics related to self-leveling sleepers for high-speed applications. So we have a collaboration with industry. So students will have the opportunity actually to work with industry partner as part of their dissertations. Hope that answered the questions, Debbie.
It certainly has, and there's been no more questions that are currently in the chat, Benny. So I think this would be a good time to say thank you to our audience for listening in today, and thank you to you too, Benny, for your time and your expertise and your excellent presentation. Particularly like the videos that you showed. And yes, just to say thank you everyone, and goodbye for now. Bye bye.